Okay. Yeah. Welcome to lesson 5 of this series. Thank you all for joining. So today we will discuss about LLMs. LLM is large language model, and then we look at OpenAI chart completions API. Chart completions API is where when you put a prompt with a question, it'll give the answer, right? So that's like a completion. So we look at chart completions API, and then we look at with the chart completions API, how can we create chatbot application? And then we look at basics of prompt engineering, various types of prompts, right? And then we try to look at some ethics and bias and responsible AI. So this is the agenda for today. Um, but before I dive into today's agenda, um, actual content for today, I did post a warm-up question. Does anybody wants to answer the warm-up question? The question is, how do you evaluate a classifier? You can come off mute and answer this question for now. So this question is from lesson 3, classification. We looked at how to create a classification model, and we looked at how to evaluate a classification model. So I'm asking about the question is, how do we evaluate a classification model? What metrics do you look at to see if the model is really doing well?
Yeah, in the lesson 3, we came across a few metrics, not just one: accuracy, confusion matrix, recall,
Right.
some of them. Yeah, ROC, AUC.
Mm-hmm.
Yeah,
Correct.
yeah.
Um, so what do we understand about confusion metrics?
That's the matrix with the true positive, false negative, false positive, true negative. Eh, uh,
Okay.
yeah, from
And
this table, we find out how how accurate the data, I mean, the output is correct from the untrained data, something like that.
got it. Yeah. Um, do you guys remember about F1 score?
Me.
Okay. So the F1 score is a combination of accuracy and recall, precision and recall actually. So if you only look at precision or recall, only looking at precision and recall, we may not be able to come to conclusion that the model is really doing well. So F1 is a balanced metric which comprises of both precision and recall. So your precision should be close to 100% and recall also should be close to 100%. F1 score also should be close to 100% for a good classification model. Okay. Okay, let's jump back to lesson 5. Thanks for the answer. Thanks for answering the question. Sorry. So natural language processing. Um, the concepts of text classification. Text classification is something like We want to classify an email as spam or not spam. That's an example of text classification. And text classification is an example of natural language processing. And machine translation, converting text from one language to another language, let's say English to Spanish. So for that conversion, we can use machine learning, and that process that comes under machine translation, which is part of NLP, natural language processing. Um, Sentiment analysis and conversational AI, building programs such as chatbots, also comes under natural language processing, right? So ChatGPT released in the month of November in the year 2022. From then, um, LLMs came to everyday use for everyone, right? Within a day, over a million people interacted directly with LLM. So this is some history. LLMs do hallucinate, but they do it confidently. They hallucinate confidently. So it's your responsibility to verify the output LLM provides, to make sure the, to make sure it is correct before you use it, right? And what is an LLM? This is a question. You people can come off mute and answer. Any guess is also fine. What is a large language model? Okay, so let's say OpenAI or ChatGPT. Whatever the question you ask, it will provide the answer. It provides the answer from wide variety of topics, right? You ask about news, you ask about history, you ask about science, mathematics, or sports, law, whatever it is, right? It will provide answer to you. How is it? How that is doing? Because LLMs are large language models. They are trained on vast amount of data, on internet data and books, etc. So that they are like general purpose models or foundational models trained on vast amount of internet data. So that's how they are able to provide answers to the questions you are asking, right? So and and LLMs work such a way that they auto-complete. They try to predict the next word in a sentence. Until the process is complete or until the answer or the response is complete, it keeps on going in loop, try to predict the next word, right? So if you give this prompt as a prompt to ChatGPT, then it will predict the next word in this sentence. And then let's say it predicted mat. The cat sat on the mat, and if you put dash and then again prompt it, it'll predict the next word. So this is how LLMs are designed to work. They are trained to predict the next word, and they do it continuously until the response is complete. Right. So in in order to predict the next word, it'll give rankings to the next word. So the next word can be mat or floor or sofa. So it has ranking on the next best predicted board. So it'll, based on the ranking, the highest ranked board, it'll fill. Right. So that is how LLMs work. Let me switch to so and some of the existing LLMs you may already know. They are These are the famous LLMs people know: ChatGPT, Claude from Anthropic, Gemini from Google, Llama from Meta. So these are some examples of LLMs, right? LLMs autocomplete at massive scale, as I just mentioned. They can write code, summarize documents, translate language, etc. And they are trained on books, web pages, and code to predict the next word, right? So yeah, let me switch here again. So that's an LLM. Um, I want to show this diagram. We don't go into deep about this concept, but I just want to give some understanding on how LLMs are trained, right? So this is the data: internet data, books, Wikipedia, research articles. This is raw, unlabeled data, huge amount of data, right? Trillions of words are used to train an LLM, right? And that is called foundational model. Foundational model is a model which is trained on a huge amount of internal data, and it's used for general purpose to predict or provide you the answer to the question, right? And you can take the large language model, which is for general purpose, and then you can apply training with the data set you have to specialize the model, right? Um, a pre-trained LLM can be further trained on labeled data set to obtain a fine-tuned LLM for specific tasks. Right? Let's say you're taking this general purpose LLM, and let's say you want an LLM which works on financial markets to give you predictions every day, right? Then you train that general purpose model on the financial data you have, so that it'll predict the financial markets every day. So that's one example, right? This and then once you train on the data set you have, then we call it as fine-tuned LLM, right? So that's an example or concept around fine-tuning an LLM. And LLMs learn supervised by using self-supervised tech learning, I think. Um, Let me see. Yeah, LLMs use self-supervised learning. So you can explore about it further. And as discussed in the diagram, you can fine-tune an LLM. That's called supervised fine-tuning because you are providing labeled data. So you are providing labeled data, so we call it as supervised fine-tuning. And LLMs also learn with the technique called reinforcement learning. So with the technique called reinforcement learning. So if you ever came across a situation while using ChatGPT or Gemini that it provides two responses instead of one response and asks you to rate the response. In general, I used to put a thumbs up on the response I like. So that is an example of reinforcement learning from human feedback. So those are some of the techniques LLMs use to learn. And this is an architecture of LLM. So let's say this is the prompt you were giving to your chat GPT, right? And that prompt is broken down into tokenized tokens. And the tokens are changed to token IDs. So LLMs are machine learning models do not understand oaths, they understand numbers. The so your input text is broken into tokens, and from the token IDs are created, and each token is created as token embeddings, and token embeddings are passed to a transformer, which has an attention mechanism, and then the transformer will provide the output. Basically, it will predict the next word in the sentence. So this is an LLM architecture. You can see over here. It's this, I mean, again, your your input is broken down into tokens, and token IDs are created, right? And from token IDs, we create token embeddings. Embedding is like a vector or a tensor. So LLMs understand tensors well, right? After that, this is embedding space. All the related embeddings are grouped together based on the context, right? So so this is an attention mechanism here in the LLM architecture. You see there is a transformer with the attention mechanism. So let's say you have two sentences, and apple is in those two sentences, but if you are asking an LLM with this sentence, the recipe includes an dash orange and grapefruit, it will predict apple here. At the same time, if you ask in the smartphone market, it will predict apple here. So the apple is understood as a device in this context. In apple is understood as a fruit in this context. So um, that's the attention mechanism doing this thing, right? Here is a video I'll play for you to understand the attention mechanism um, real quick. So
Hi, Modi. We are not
Um,
able to hear anything.
okay, let's see.
So Murali Krishna,
Um,
I think there's a setting in the audio. So if you're on desktop, I think there's like a little drop down caret next to your audio where you can share your output, and that may do it. But it
mm,
also might be in the share settings. I mean, Zoom changes all the time, so I'm sorry.
I think audio should be shared before joining the.
okay. Can you guys hear me now?
Yes.
We can hear you. Yeah, we just couldn't hear the video playing because it's the
Okay.
audio output of your computer.
Okay. So I think I'll skip the audio for now, but I want to show the attention mechanism. You people can check it later. Let me share again. So are you able to see
Yep,
the
we can see the
screen?
YouTube page. Thanks.
Okay. So you as you can see here, right? This is a phone and this is a strawberry. And if there is an apple, if it needs to be categorized, um, in the embedding space, based on the input, it will categorize as either phone, belongs to electronics, or belongs to fruits. So that's an attention technique. Okay. Um, so yeah, so based on the attention, right? So the embeddings have an attention now, and it is passed through a neural network, and you get an enriched embeddings. Ultimately, you get the next predicted vote. So this is to give some context on the LLM architecture. Okay. So here is an example to understand how the tokenization works. This is an OpenAI tokenizer to give an understanding on how the tokenization work, right? If I put an input on what is a machine learning algorithm, right? So this input, if you give to LLM, let's say ChatGPT 5, it'll convert it as 6 tokens. You can see over here what is a token. Is 1 token. A is a token. Machine is a token. So whatever the input you are giving, it's broken down into 6 tokens. And then as per the LLM architecture, it'll be changed to token IDs. Then it will be sent to transformer with attention mechanism, and the output will be predicted. Okay. So here is the code to visualize the embeddings, right? You were you were providing the model to create the embeddings, and you are creating embeddings by calling. You are creating an OpenAI client, and then client.embeddings.create. You are creating an embedding. Basically, you can visualize the embeddings actually. So you can check this code. Um, then I can ask you a question. What is a token? Right? LLMs do charge based on the usage, how the usage is calculated. So the usage is calculated based on number of tokens, you number of tokens in the input and number of tokens in the output. Right? If you give a bigger prompt, let's say if you give a PDF document as a prompt, and if the PDF document has 20 pages, then then all the 20 pages of text will be broken down into tokens for LLM to understand. So each token, so the cost is basically derived based on how many tokens the input is and how many tokens the output is. So if your question is too big, if you're questioning with the PDF attached to an LLM, then the cost for that request will be high. So this is how you need to understand. So the cost is calculated based on tokens. I want to quickly show this. So why tokens matter? Cost. Most of the APIs charge per token usage. More tokens means higher bill, right? And LLMs have input limits. If you have ever encountered an error saying that the context exceeded the limit or the input exceeded the limit, that's because you are giving lot of content in the input. Let's say if you go to Gemini, you can only attach 10 documents. You can't attach more than 10 documents because that LLM can handle those many tokens worth of 10 documents. So there are input token limits for LLMs. So that is one other important thing about tokens, right? Each model has the input token limit and output token limit. The number of tokens it is trained to handle, right? So you can check the token limits of popular LLMs as well in the web. Okay. I think we discussed about embeddings, how LLMs generate text. I think we discussed this. Okay, let's go to chart completions. So the next topic is OpenAI chart completions API. A completion refers to the output the model generates in response to your input, right? So you keep your OpenAI key. This is configuration step for OpenAI. I think you might have received the OpenAI key already. You have to keep the OpenAI key in your local environment variables or in .env file. If you keep it in .env file, make sure this .env file is in git ignore, because you should not commit this .env file to GitHub. You should not push this .env file to GitHub, so that in case if you push it, someone else can use the API key and the owner of the API key will get the bill. So you should be conscious to not commit the API key or share with others. So that's one important thing to remember during the setup. So once you include the API key in the environment variables, then if you call load_.env, your API key will be loaded. After that, you can import OpenAI from OpenAI. This is how you create an OpenAI client. So this is OpenAI client, ChatGPT client. It has completions and create function. So just a second. So you were telling which model your query needs to go, your input or a prompt needs to go. And this is the prompt. The content has all the input you are providing, the role we are saying as user, and temperature, we are setting it as 1.3 n equals to 1. We discuss about this in the below. So this is how you make a request to the LLM to get a response, right? Um, if you go to ChatGPT in the browser and if you put your request, this is what is happening behind the scenes. That request is being sent to ChatGPT model, and then you get the response. So how do you read the response? Response.choices of 0.message.content. This is how you read the response, right? So your response object has three. It has choices. Here is where the actual response is. It has dot usage. You can see the number of tokens used with this dot usage, and the model actually tells it which model we are hitting, right? So other parameters, temperature is basically, I said that LLMs do hallucinate, right? So if you keep the temperature very low, if you keep it 0, um, the LLM output is more deterministic. Randomness is very less. There is zero randomness, I would say. The responses are more deterministic. If you keep temperature as 0, if you ask a question to an LLM 10 times, for all the 10 times it will try to provide the same answer. But if your temperature is close to 1, then it will give 10 different answers if you ask the same question 10 times, because the randomness is there in the responses it generates. So it's better to keep the temperature near to 0 in order to get a deterministic output from LLM. So n is basically number of responses you want to get from LLM. If you give 1, it will give 1 response. If you give 4, it will give 4 responses, top 4 responses matching to your input. So the maximum tokens. So while querying, you can set token limits. Let's say you were working in an organization where you have Copilot access, and they put some limits on the maximum tokens that can be used for one request, right? Um, I actually came across this situation. So in between, if you are in agent mode and if your maximum tokens are reached, but it is not still finished with the response, then it will give an error saying that you reached the maximum token limit. Right. So the maximum token limit is to control the usage. So you can set max tokens while calling the completions API. Okay. So any questions on this? You can put it in the chat if you have any questions on this. Okay. Okay, I'm moving on. So that is about completions API. And then we look at how to create a chatbot. So the API calls are stateless. So the LLMs or the API calls doesn't have memory, right? If you're building a chatbot, you were asking the fourth question, then with the fourth question in the prompt, you have to send all the prior three questions as well, so that LLM has the context of all the four questions. So that is how you build a chatbot. you can see over here, here you can see basically we are looping through, and for messages we are appending the context every time, and all the messages are being sent when we query or send a request to completions API. Right? The messages is basically an array of all the previous prompts. It has the role and it has the content. The content is your prompt, right? So, and then same concept, you fetch the response from the response object. So this is how you build an chatbot application. Right, you can see over here, the messages is basically an array of all the previous chat questions you were asking. So then comes to prompt engineering. I'll switch to, so I can ask a question. So now you know how LLMs charge. They charge based on number of tokens used in the input and the response. So now really prompt engineering is important. You have to provide the right information while you query the LLM or when you prompt the LLM, so that your token usage is limited and your bills are less, right? So that's where prompt engineering plays a role. So there are different types of prompts. We can discuss about that now. I'll switch to this. So prompt is an input or a question to an LLM. And what is a prompt engineering? It's an art of optimizing the input, the prompt you are asking, in order to get the desired outcome from the chat GPT or an LLM, right? Sometimes you will ask the question, you may not get the right response. Then you tune your question, and then still you won't get the right response. Then the third time you will ask your question correctly, and it gives the desired response. So that is kind of prompt engineering, right? How well your prompt is based on that LLM also responds. So it's always better to be detailed when you're prompting and be specific about what details you require. And let's say you were asking a question, you want a true or false response, then you can be specific. In your response, you just tell me, is it a true or false? Otherwise, it may give you a big paragraph and that adds up to your token usage, right? So it's always good to be detailed and specific in the prompt, right? And sometimes you need to guide the model to think through the answers. When you guide the model to think through the answers, it is able to provide the right responses to you. And prompting is an experimenting process and iteration process, right? Yeah, this is an example of being detailed and specific. So how do we guide the model to think through answers? Here is an example of chain of thought pattern. So if you are asking it to solve a problem, you can provide two examples to LLM, two examples of a question and answer. Then you can ask the third question. Then it'll try to follow the pattern you have provided in the first two questions and answer the third question. So that's where is guiding the model plays a role, right? Sometimes, sometimes you may be thinking too much to prompt or to prompt in a better way, but that's okay. Sometimes you can prompt it and then check the response and then tune your prompt. So this is basically an iteration process. You have an idea, you prompt it, LLM will give the response. You tune your prompt, again you will get response. You have to do this until you get the desired outcome, right? Yeah, these are some prompt types. We can look at our tutorial also about the prompt types. Um, Let me switch here. So we discussed about temperature, controlling the randomness. So the API is stateless. So for chart, if you're building a chatbot application, you need to send the information about previous questions as well. For each question you ask the LLM, right? So yeah, so there is zero shot prompt, one shot, few shot prompts. Zero shot prompt is where you don't provide any example to the LLM, but you just ask the question. So it'll figure out the answer to your question. You don't provide any examples for it. One shot prompt is where you provide one example to the LLM so that it'll use that one example to reason or answer your next question, right? So that is one shot prompt. Few shot prompt is where you give more than one example to LLM. So based on that, it'll provide the response. And I think we touched on chain of thought prompt. Chain of thought prompt is where actually you will basically telling the LLM the way to think, right? So um, in the other example here, I'm saying first add 3 plus 4, then to the result, I think this is wrong. So to the result, we are telling to add the next number and we get the result. And to that result, we are telling to subtract the next number. So this is how we are telling it to reason about. So this is an example of chain of thought prompt pattern. And then if you ask next question, it'll try to reason the same way as this chain of thought pattern, right? And sometimes you can ask the LLMs to give a structured output, right? You can say from now on, for all the questions I'm asking, your response should be in a JSON format. Then LLM will provide you the responses in JSON format. So that is another example. Yeah. So yeah. So in the prompt, you need to be clear and specific, right? Prompt is an iteration process. As I said, iterative process. You prompt it, check the response, then tweak the prompt, check the response. You repeat this process until you get the desired outcome, right? This is the chain of thought prompt, asking the model to reason step by step. I think we already saw the examples. Uh, Zero shot. This is an example of zero shot. What is 15 plus 27? You're not giving an example, you are just giving the question. So one shot prompt is basically categorize the animal as mammal, bird, or reptile. One example I'm providing, eagle is of type category bird. This is one example. And now we are asking it to categorize snake. Based on the example we gave, it will try to categorize. So few shot is like we gave more than one example. In this case, we gave 3 examples for LLM. So it'll try to predict based on those examples. So yeah, we can ask in different formats also the response. So this is one example. I'm telling LLM that the response should be like this. It should be topic colon and then the topic value, price colon the price value. This is the output format I'm asking the LLM to provide. It will provide in that format. If you ask it to provide in bullet list, it will provide in bullet list. So that's about prompt engineering. And one last thing I missed. So this is moderations API. So ChatGPT has moderation or guardrail APIs, right? Let's say you are asking questions like, I want to kill my neighbor. If you ask this question to LLM, then it will not give you the answer because the moderations APIs basically evaluate the input. And if the input is belonging to this type, these categories, it will not respond to you, right? So when you are, let's say you are building an application, behind the scenes you are querying LLM, but your front end user is asking some of these questions, then you will basically check the moderations response from LLM, and then if it is harmful, then you don't respond to the customer. So this is the moderations API. You can check if it is flagged or not. If it is flagged, you can tell the customer that I'm not supposed to answer these kind of questions, etc. So this is about moderations API. You can explore further on this. I think that's all for today. In the next lesson, which is lesson 6, we discuss about LLM augmentation. We discuss about retrieval augmentation generation. It is a technique where now we know about LLM, how LLMs cost the user based on tokens, right? Let's say you were building a chatbot application, but you have so many PDFs, which has all the answers to the questions user is asking. Every time you prompt the LLM, you cannot attach 100 PDFs just to answer a simple question. The answer to the simple question is in PDF 1 in paragraph 4. So you can basically, with the prompt, you can just put that paragraph only, which is related to the user question, and then your token usage is very limited versus sending 100 documents and asking LLM to figure out where the answer is. So this is basically the concept of retrieval augmentation generation. Instead of sending 100 documents, we retrieve the related content from the documents and put it in the prompt instead of putting all the 100 documents in the prompt. So this is RAG. This is very important concept. And then we look at how we use Llama index to perform RAG in the next lesson, which is lesson 6. That's all. Thanks for joining. I'll stop the recording.